Your eye color isn't just a feature of your appearance, it's actually a fascinating survival tool that helped your ancestors conquer the planet. Over 70% of humans have brown eyes, but the remaining 30% carry genetic mutations that tell an incredible story about human migration, adaptation, and evolution. Let's take a deeper look at what your eye color truly means. Brown eyes are the ultimate biological shield. That deep, rich color comes from melanin, a powerful pigment that absorbs up to 90% of the light entering your eyes. Research from the University of Copenhagen confirms that melanin doesn't just give color, it acts as a natural sunscreen embedded right in your iris. For early humans crossing the African savanna under intense UV radiation, this wasn't just cosmetic, it was a matter of survival. Melanin absorbs harmful ultraviolet radiation before it can damage the DNA in your eye cells. Brown eyes don't just offer better protection, they also perform better in bright light. Because melanin absorbs light rather than scattering it, people with brown eyes experience less glare and maintain clearer vision under intense daylight. This is why brown eyes are more common in populations closer to the equator. They appear rich and uniform, rarely shifting in tone. But if you catch them in candlelight or low sunlight, you might notice golden or amber flashes as scattered light plays across the layers of the iris. That's not a change in color, it's physics revealing the structure of your eye. Now, blue eyes are a bit of a mystery. Every single person with blue eyes on Earth descends from one common ancestor who lived between 6,000 and 10,000 years ago. Research in human genetics traces this back to a single genetic mutation in the HERK2 gene, which switched off of brown eye production. Before this mutation, everyone had brown eyes. Interestingly, blue eyes aren't actually blue. There's no blue pigment in your iris. Instead, your eyes contain almost no melanin. When light enters, shorter blue wavelengths scatter back out, while longer wavelengths pass through. This scattering effect is the same one that makes the sky appear blue. As a result, your eye color can shift from icy bright to soft gray, depending on the lighting. Scientists believe this mutation occurred during the Neolithic expansion, when humans migrated from the Black Sea region into northern Europe. But here's the mystery. Why did blue eyes spread so rapidly? In just a few thousand years, blue eyes went from being non-existent to being found in 70 to 95% of the population in northern Europe. Some suggest blue eyes offered an advantage in low-light environments, allowing more light to reach the retina and enhancing vision during long northern winters. Another theory is that blue eyes became a sexual attraction due to their rarity, accelerating their spread through mate preference. Recent DNA analysis of ancient remains has even revealed that some early Europeans had blue eyes but dark, African-like skin, proving that light eyes evolved before skin lightening. This shattered the old idea that blue eyes were merely an accidental byproduct of pale skin adaptation. Gray eyes, on the other hand, are extremely rare, found in less than 3% of the global population. They contain even less melanin than blue eyes, resulting in diffuse light scattering across multiple wavelengths, not just blue. This gives gray eyes that distinctive steel-like appearance that can shift from silver to slate to subtly green depending on the lighting. Researchers believe gray eyes evolved as an extreme adaptation for low light sensitivity, especially in regions like northern Europe, where overcast skies and limited sunlight were constant challenges. The broad wavelength dispersion makes gray eyes neutral in tone, but they can also be emotionally harder to read. There's less color variation to track, which could explain why gray eyes are often associated with wisdom, emotional control, or detachment. Unlike blue eyes, which can appear bright or warm, gray eyes maintain a cool neutrality, often giving them an enigmatic look. However, the lack of melanin also means people with gray eyes are more vulnerable to UV rays, just like those with blue eyes, and need to be extra cautious about sun protection. Green eyes are the rarest common eye color on Earth, seen in just 2% of the global population. So, what makes them so uncommon? Green eyes require a precise genetic combination involving at least 16 different genes working together in perfect harmony. Too much melanin, and the eyes would be brown. Too little, and they'd be blue. Green eyes sit in that narrow sweet spot, containing moderate levels of melanin plus a yellow pigment called lipochrome. When light hits this combination, it creates that unique green hue. But here's what's really special about green eyes: they're chemically unstable. Research shows they are highly sensitive to environmental changes, often appearing mossy in shadow, golden green in bright light, and sometimes even shifting toward hazel or blue gray, depending on surroundings. This dynamic quality has made green eyes a focal point of folklore across cultures. In medieval Europe, they were sometimes linked to witchcraft and supernatural abilities, while in Greek mythology, they were thought to carry special powers. Even today, they're associated with mystery, intuition, and creativity. From an evolutionary standpoint, green eyes may have provided an adaptive advantage in temperate climates with variable lighting, such as forests and mountains. Their moderate melanin offers some UV protection while still allowing enhanced light sensitivity, striking a balance between brown and blue eyes. Genetically, green eyes are most common in people of Celtic and Germanic ancestry, especially in Ireland and Scotland, where up to 86% of some populations carry the trait. But given the right genetic combination, green eyes can appear in any population. Hazel eyes are incredibly unique, with the ability to genuinely change appearance based on lighting, clothing, and surroundings. This isn't an optical illusion, it's a physical phenomenon driven by intermediate melanin levels and traces of lipochrome that interact differently with light. One moment they might look green, the next golden, then brown. This color shifting ability reflects their evolutionary advantage in mixed environments: sun, shade, changing seasons, and variable climates. Hazel eyes offer moderate UV protection while maintaining reasonable light sensitivity, making them adaptable to diverse lighting conditions. About 5% of the global population has hazel eyes, with higher concentrations in people of European and Middle Eastern ancestry. What's particularly fascinating about hazel eyes is their unpredictability. Two people with hazel eyes can have completely different distributions of color in their irises. One might have more green with brown spots, while another might have more brown with green rings. This variation has made hazel eyes seem mysterious and emotionally expressive throughout history, bridging the spectrum between dark and light eyes with one of the most dynamic appearances in the human population. Amber eyes are extremely rare, found in less than 5% of people, and often mistaken for light brown or hazel. However, amber eyes are distinctly different. They contain high levels of lipochrome with very little melanin, resulting in a golden, copper, or honey-colored iris that doesn't change with lighting. Unlike hazel, which shifts color, amber eyes stay richly golden under all conditions. This stable coloration is also common in predatory animals like wolves, owls, and eagles, which may explain why amber eyes can feel instinctively intense or commanding. Some researchers suggest humans subconsciously associate this color with alertness and confidence, traits that could offer subtle social advantages. From an evolutionary standpoint, amber eyes likely evolved less for functional light adaptation and more as a visual signal. Their striking appearance may have been selected through mate preference rather than environmental necessity. Genetically, amber eyes are most often found in individuals of Southern European, Asian, or South American descent, though they can appear in any population with the right combination of genes controlling melanin and lipochrome production. Black eyes, often mistaken for true black, don't actually exist. What appears black is simply an extreme concentration of dark brown melanin, so dense that the iris looks completely black. This saturation makes them the most effective at absorbing light, offering maximum protection from UV radiation and glare. In equatorial regions where sun exposure is constant and intense, black eyes provide a significant advantage. Research confirms that darker eyes filter harsh light more effectively and stay visually stable in all conditions. Unlike lighter eyes, which scatter or reflect light, black eyes absorb nearly everything, minimizing eye strain and significantly lowering the risk of UV-related damage over a lifetime. Though black eyes are often overlooked as a distinct category, they are common in populations from Africa, South Asia, and Southeast Asia. Culturally, black eyes are linked with themes of mystery and strength, often perceived as powerful due to their depth and ability to mask emotional expression. The dense melanin makes it harder to detect pupil dilation changes, which some people interpret as inscrutability. Finally, heterochromia, where someone has two differently colored eyes or noticeable variations within a single iris, affects less than 1% of the population, making it extremely rare. In most people, melanin is evenly distributed across both irises, but heterochromia occurs when this symmetry is disrupted, usually due to minor genetic mutations or localized changes during early development. Historically, heterochromatic eyes have been seen as signs of duality, supernatural connection, or divine favor in various cultures, possibly because they break the visual symmetry we subconsciously expect in human faces. Your eye color holds the story of your ancestors, their migrations, their adaptations, and the environments they conquered. From the melanin-rich brown eyes that crossed ancient savannas to the blue-eyed mutation that spread through Ice Age Europe, each color represents a chapter in human evolution. So, the next time you look in the mirror, remember, you're not just seeing a color, you're seeing thousands of years of survival, adaptation, and the incredible genetic lottery that made you exactly who you are.